Assalamu alaikum. Everybody is welcome.
वालेकुम सलाम सर।
There. Okay, ji. Last time we were discussing there. Are you in the meeting?
यस सर।
अच्छा वो उसको कह दो रिकॉर्डिंग के लिए, ठीक है?
यस
Okay, ji. Last time the compressive strength of the cement mortar that was discussed. I told you in the beginning that PRC lab is basically this has been devised to focus the determination of the different properties of the ingredients, all ingredients, specifically the basic ingredients like cement, sand, cement, sand, coarse aggregate, similarly water, all and what are the basic. Hold on, please. Now the focus is to find out the different basic properties of the ingredients of the concrete, and also to assess the final properties of the mortar or the concrete. This is our focus in PRC lab. As you know that the properties of the concrete, which is the final product after mixing the ingredients, which is the final product, the properties of this concrete will be depending upon the properties of the individual material, cement, sand, aggregate, and water. So before finalizing or before assessing the properties of the concrete, it is necessary to assess and find out the properties of the ingredients. Okay. Now,
excuse me sir.
जी जी.
सर काइंडली ऐड कर दें, बच्चे बाहर वेट कर रहे हैं वो मीटिंग में प्राइवेट.
Now, I also shared with you some sample videos. Sample videos were also shared with you, and you might have gone through that one. If there is any confusion, that can be pointed out before we are moving further. Akib, बंद करो. Any confusion, any question from any person from the class? Yes? You may raise the question which are relevant to the previous jobs. Anyone? ज़ैर, ठीक है? ये अभी तो कोई.
यस सर, ठीक है सर, समझ आ गई वीडियोस की.
So I may continue. So today we will be addressing an which is the determination of fineness modulus of coarse and fine aggregate, from different sources. Everybody is required to keep the class notes registered with him. Everybody, please. Class notes register with him, with her. Everybody should keep class notes registered. If all the classes are continuing online, then certainly it will be the requirement of the OBE to submit as an as a proof for the conduct of the classes, your class notes register that will also be submitted, as you have already submitted those class notes registers in structure analysis. So now today we are going to find out the fineness modulus. Now what is fineness and fineness modulus of course and fine aggregate? As you know that coarse aggregate, coarse material is greater than 75 micron, greater than, this is wrongly written over there. You should change it. It will be detailed under ASTM C3165. Okay, it is for coarse material. It is greater than 75. Please change it. It is PDF format, so at this moment I cannot change it. So this is 75. Similarly, for fine material, it is ASTM C117, less than 75 micron, 75 microns. Now, moving towards the first of all, the what is coarse and fine aggregate? If the material is passing through sieve number 4, and its size is 4.75 millimeter, 4.75 millimeter, then it is fine aggregate, and if it is retaining on sieve number 4, it is coarse aggregate. It is well known to you, and you have gone through this one in your geotech lab as well. Geotech lab, fine and coarse aggregate.
सर ये ना कुछ स्टूडेंट्स वो कह रहे हैं कि मैं ना एडमिट करते हैं, वो मीटिंग वेट कर रहे हैं बाहर लॉबी में।
यार ये क्यों ऐसे हो जाता है? लेट कमर्स ही होंगे और क्या है? Now, what is the approach and what will be the outcome determination? If once you have obtained the fineness modulus, what will be the outcome? What will be the advantage? Advantage basically, this is being done through the gradation of the material, through the gradation of the material. What is gradation? If you are finding out the proportion of the different ingredients, the sizes of the different particles. If you are finding out the proportion of different sizes of the particles in a given sample, different sizes of the particles in a given sample, then it is known as gradation. It is known as gradation, and you have gone through this one in your geotech lab. So we will be performing the gradation analysis, and then we will be finding out the fineness modulus. And what this information gives you? It helps in finding out the gradation of the material, and that is the well graded, fine graded, uniformly graded, and this sort of gradation has already been known to you. Well graded material, fine graded, poorly graded, gap graded, CR.
Yes, sir.
Is it okay? ठीक है, समझ आ रही है बात?
Yes, sir. Yes, sir.
Okay. So the first outcome after conducting this job, that is the gradation of the material. And I told you that what is the gradation of the material? If you are finding out the proportion of different particles, different size particles from the given sample, it is the process of gradation. Secondly, we can find out, we can have an idea that whether the material is fine or coarse. This is second. The next is, it also indicates the surface area. If the material is fine, the surface area will be less or more. Yes? Anyone? Yes. If the material is fine, then the surface area will be more. The example of this one that may be stated like this one is that if you are having any large stone, ठीक है, just measure the dimension area जो है वो surface area that can be measured through the water replacement method or any other method. Now you break it into number of pieces. Then you need to find out the surface area of each and every particle. What will happen? It will certainly be more as compared to the stone, parent material, from which this has been obtained. These particles have been obtained. So if the material is fine, it will be more active, it will be having more surface area. It will be more active and it will be more, it will be having more surface area. Similarly, if the material is coarse, it will be having less some surface area, it will be less reactive. Okay? So now, what is the difference between fine and fineness modulus? Fineness and fineness modulus. If I say surface area is more, if it is more, what does it mean? Fineness modulus should be less. Is it okay? Am I right? No way.
Yes, sir.
Surface area is more, so it fineness modulus is less. अगर ये लेस है तो हम क्या कहेंगे कि मटेरियल इज मोर फाइन. Material is more fine. So there is a reciprocal, very similar to this one. Very similar to this one. Surface area is reciprocally related to the fineness modulus. The same is with the fineness of the material. Fineness modulus is something else. Fineness is a qualitative value. Fineness is a qualitative word. Fineness modulus is a quantitative measure of the material. Quantitative. Fineness modulus is expressed in terms of some numerical value, but fineness is a qualitative word. Fineness. Acha, if the material is fine, more fine, it will be having less value of the modulus. So very similar to this expression, surface area. If I write over there fineness, then it will be reciprocally related to the fineness modulus. Is it okay?
Yes, sir.
Anybody from the class, if you are having any confusion, anybody? 56? 56?
Yes, sir.
56? 56?
Yes, sir.
तो ऊंची बोलो. Is it clear?
Yes, sir.
एहतशाम. एहतशाम.
Yes, sir.
ठीक है, समझ आ
Yes,
रही है?
sir.
समझ आ रही है बेटा?
Yes, sir.
ओके जी. लाइबा. लाइबा
Yes, sir.
समझ आ रही है?
जी sir.
If you are having any query that can be pointed out without any hesitation, this is your duty to raise the question, and this is our duty to make you satisfied and give the detailed description. Now, the lower the surface area, required amount of fresh cement paste to cover the aggregate particles will be less, and thus less water is required. So if the Material is fine, it will be requiring more water. If the material is coarse, it will need less water for its lubrication. Then the it should be remembered that fineness modulus must be must be more high for fine aggregate, and generally the fine aggregate should be having the values between 2.3 to 3.1. This is given by Astm for the fine aggregates. At the same time, I should say that if the sand, that is the fine material generally, if the sand is coarse, then it will give you more workability. It should be remembered. It will give you more workability. It will give you more workability as compared to the fine sand. Like if you are using large sand, then it is coarse. So it will give you more strength and more workability as compared to the fine material like sand from the Ravi river Ravi. Ravi sand will give you less workability. What is the reason? The fine material that will stuck and that will be accumulated, that will get flocculated, एक ही जगह इकट्ठी हो जाएगी अगर फाइन मटेरियल है, और अगर कोर्स मटेरियल है, the particles will get separated naturally and it will be giving you more workability as compared to the fine material. So it should be remembered, wherever you are producing the concrete, the fine material must be coarse, Okay. Now the apparatus that is very similar to the gradation procedure as you have done earlier in your geotech lab, that there is a set of sieves and which have been arranged one above the other, starting from the top with large opening, you can see, and then reducing the size of the aperture as we move downward. So standard set of sieves, and then sieve shaker if you are using the gradation procedure through mechanically, and then the aggregate sample. Now this aggregate sample will be almost 300 grams. Now the material that should be oven dried, it should be free from the moisture on the surface. It should be free from the moisture on the surface. Okay. Now what is fineness modulus? It should be remembered, it is the cumulative combined percentage retained on standard sieve 150 microns. 150 microns means sieve number 100. Sieve number 100. BS standard sieve 100. Sieve 100. And above divided by 100. So this is the fineness modulus. This is the fineness modulus. Cumulative percentage retained on standard sieve. So what will be, what does it mean? This, if this is sieve number 100, it will be sieve 80, it will be 50 or 60, it will be like this one, you will be arranging it in an ascending order. So ये जो है, ये size के लिहाज से, so it will be sieve number 100. Below that, there will be pan sieve 100, and we will be moving up till it is sieve number 4 or above. Now, what is fineness modulus? It is a single factor, or it is an empirical number that results from the sieve analysis, and if the value of fineness modulus will not change if we add sieves above. It means if this is sieve number 4, I can arrange, I can place the sieves with large opening above this one. It will make no difference because by definition, Fineness modulus is the percentage of the material retained on sieve number 100 and above. So if this is sieve number sieve 100 and above you are arranging number of other sieves, it will make no difference and it will give you the same fineness modulus value. What is sieve analysis? You will be arranging the sieve one above the other and you will be performing the sieve analysis. 1 millimeter is equal to 1000 microns. Now 5 millimeter is the dividing line between fine and coarse aggregate. This is basically 4.75, but in general it is taken to be 5 millimeter. And function is to check. Function of the sieve analysis is their gradation. We will be finding out the gradation. We are getting the gradation of the provided material. And this gradation will help in assessing the workability and average size of the particle. Workability. I told you if the material is well graded, it will be giving you more strength. Similarly, if it is coarse, then its workability will be more. And now for the coarse aggregate, for finding out coarse aggregate gradation, this is the standard set of sieves as per Astm, and these are the non-standard set of sieves. Okay. Similarly, for the fine aggregates, this is the series and the sequence for arranging the number of sieves one above the other. That there will be 10. Above that is sieve number 100, 50, 34, and sieve number 4. Even if you are placing these sieves above this one, this is 2.36 and 4.7, 9.5 millimeter and 19 millimeter. Even if you arrange above this one, 9.5 millimeter and more aperture size, it will make no difference in the value of fineness modulus. Okay. Now, how can we assess the quality of good sample? Quality of good sample. As per Astm, the good sample is defined. That is also given. That has also been specified by Astm standard. The good sample is a sample which is whose gradation curve lies between the minimum percentage passing and maximum percentage passing as specified by Astm. As specified by Astm. And you know that, and you have also drawn the gradation curve in geotech lab, that on one side there is a cumulative percentage passing, on the other side is the sieve size on the log scale. Now these are the limits which have been given, lower limit and the minimum percentage of passing according to specification and maximum limit according to specification. You will be drawing on the graph paper, you will draw the gradation curve, minimum and maximum values, limits. This is lower bound macadam, lower bound, and this is upper bound as given by Astm. Where from this has been drawn? This is given by Astm. Astm gradation curve requirement for fine aggregate. You can see that this is sieve number 100 and above. It is given that percentage passing in from this material 9.5, from this size 4.75. For the fine material, the percentage passing should range between 95 to 100. 95 to 100. It means minimum value is 95 and maximum is 100. So minimum value is 95, maximum value is 100. Then you will, this is minimum value and this is maximum value against one size. This is minimum value, this is maximum value. Okay? Uzair?
Yes, sir.
Anyone else from the class? Hamza? Hamza? Are you understanding it? Is it okay? अच्छा, Ayan, Ayan, Ayan,
Yes, sir.
Anis,
Yes, sir.
हाँ जी समझ आ रही है बात की?
Yes, sir.
Arima,
Yes, sir.
any confusion or any question?
No, sir. Thank you.
Okay. So ASTM gradation for fine aggregate, it should range between for 4.75 size, millimeter size. It should be 95 and it means if this is size of number 4C, if it is the size of number 4C, and then percentage passing should be between 95, this is minimum, maximum is 100. Okay? Similarly, if it is C number, with if this is with 600 micron, its minimum value of percentage passing should be 25 and then 60. It means it is 25 and this is 60. Okay? The same, similarly, this is 100 microns, it is 2 and it is 10. So this way, you can draw the ASTM gradation curve. This is a ASTM limitation curves. Then you will be performing the test on your given sample and you will be drawing the line or the gradation curve. If your line gradation curve that falls between these limits, then this is a good sample. This is a good sample. This will be labeled as a good sample, or otherwise it is not a good sample. Now this is just the support from the ASTM to use the material which is lying in between these two limits. Otherwise, you can use the material. It will be depending upon the choice of the engineer at the site, whether he is using a good material sample or not. If he is following ASTM minimum and maximum limitations or not. So, however, as per ASTM, this has been labeled this material, which is having its gradation curve in between these limits. In between, this has been labeled as good sample. And preferably, it will be giving you, it should be used as it will be giving you better result. It will be giving you better result. Now this is for the fine aggregate. Similarly, this is for the coarse aggregate. For the coarse aggregate, for this size, if the material coarse aggregate that is having maximum size of 37.5 millimeter and all other material is less than this one size, then for this one it will be minimum value will be 100 and 135 and 70, 10 and 30. If the size is 19 millimeter, the maximum, then it will be 20 and 55, 0, 10. If it is less, 12.5, then this will be the minimum and the maximum values. So these are the gradation curves for the good sample for fine aggregate and coarse aggregate. And your sample preferably should lie between these two limits, which have been given by ASTM. Now the procedure was very simple. Whether you are using the sieve shaker, this is, you can see, you are well aware of this one. This is a sieve shaker. You will be arranging the set of sieves, and there is a provision of provision of the sieving process, to and fro, आगे पीछे, दाएं बाएं, in rotation, clockwise and counterclockwise. So you can, even if you are not having the sieve shaker, then manually this should be performed in this way: forward and backward, left and right, and clockwise, counterclockwise motion. Then you will be finding out the material that is retained on each sieve. Then once you have found, you can see this is pan. This will be sieve number 100, and all these sieves are with large openings. As we move up, opening is large. Then what will we do? Certainly there will be retention of some material over there. Some material will be retained over there, over there, over there, over there, and then over there. And the material that is passing through this sieve number 100, it will be collected in the pan, but it will not be considered in calculations. It will not be considered in calculations. It will be ignored. This material which is collected in the pan will be ignored. And then we will be finding out the percentage retained on this one, कितने percent इस पे retained हुआ, इस पे हुआ, इस पे हुआ, इस पे हुआ, इस पे हुआ और इस पे हुआ. All these percentages will be summed up. All these percentages will be summed up. All these percentages will be summed up. All these percentages will be summed up, and it will all this will be divided by 100. So this is the cumulative percentage retained on standard sieves of sieve of 100, sieve number 100 and above, divided by 100. So it will be giving you the final. Also, there is a provision in the sieve shaker that it gives some jerk देता है, मतलब एक झटका लगाता है. तो यही प्रोसीजर आपने मैन्युअली भी करना है, frequent jolting. So this process should be continued for 3 to 5 minutes, and you will be finding out the percentage retained, which is on sieve number 100 and above, and this will be giving you the fineness modulus. Following points must be kept in mind. Only some of the values of standard sieves, and do not the values of the non-standard sieves. उनको आप ignore कर दें. That should not be. If you are not having standard sieve as standard sieves, but you are having the non-standard sieve, then the material from the non-standard sieves should be ignored. At the sieve of 100 and above sizes, if any standard sieve is missing, we may use the next higher. Adding extra sieves does not change the value of the fineness modulus. I have told you, because this is sieve and above, related to sieve 100 material retained on sieve 100 and above, so it will make no difference. As far as the calculations are concerned, this is for the fine aggregate. You can have the same set. You can see that this is C pair, C100, 50, 30, 16, 8, and 4, and above. Even it is 3 by 8, 9.5 millimeter, 19 and 7 millimeter. All these will be arranged in the same way, and you will be putting the fine material. And if it is material, then certainly it will be passing through these fine to other sieves. ये 4 से गुजर जाएगा, ये सारी की सारी खाली रहेगी, 4 से मटेरियल गुजर जाए, और जो मटेरियल गुजरेगा उन सब का आपने परसेंटेज निकालना है कि कितने परसेंट वो एक सीव पे रहा, और देन यू विल बी एडिंग अप ऑल दीज परसेंटेजेस, देन दोज परसेंटेजेस will be written over there, and the material is retained on pen. It will not be, certainly it will be collected in the pen. It will not be considered, and summation will be divided by 100. It will give you the fineness modulus of the fine aggregate. Similarly, the same that will also be repeated for the coarse aggregate, that you will be having the same set of sieves which have been used for the fine aggregate, and then you will be putting the material on and in the top sieve. Then you will perform the sieving process. You will see that the material will not be passing through all these sieves. Material will not pass through these sieves. If the material is passing through sieve number 4, then it will be ignored. It is this process is being done for coarse aggregate, not for the fine aggregate. Then all weights retained on this sieve, this sieve, this sieve, all these will be written over there. Then we will be finding out, and the summation must be 100 ग्राम 100 या जितना भी आपका मटेरियल आता है. If you have taken 300 grams, then it is recommended that 300 grams should be taken for the fine aggregate. Similarly, 500 grams that can be taken for the coarse aggregate. Then all these percentage weights retained should summation should give you the total value of the material, the sample that you have sieve analysis. तो जितना आपने sieve analysis के लिया इन सब को आप जो है सम ये सारे का सारा उतना होना चाहिए. If it is 500 grams, all weight retained must be 500, and if not, it means there was some material that passed through sieve number 4. Then you will be calculating the percentage weight. कितना जो है वो percentage यहाँ पे रहा, यहाँ पे, and then you will be finding out the cumulative. How this cumulative is found? This value will be over there as it is. Then this value will be added with this one, and you will write over there. This will be added with this and written over there. Added with this one, and this will be written over there. Is it okay? Is it okay? There.
Yes, sir.
समझ आ रही है?
Yes, sir.
एक्सक्यूज मी सर.
हाँ जी फरहान.
सर कुछ बच्चे कह रहे हैं लास्ट
बोलो
में ऐड कर.
बोलो शाबाश. हाँ आपकी आवाज. हाँ
सर ऐड कर दें बच्चे कुछ कह रहे हैं.
क्या जहर ये क्या
सर एडमिट कर दें.
सर
एडमिट
वो
कर दिया यार. वो आप छोड़ें. आपको अपनी फिक्र करनी चाहिए. आप वकील ना बने. मैं देख रहा हूँ सबको. हाँ जी हसीब अब्दुल हसीब.
यस सर.
हाँ बेटा ये बताओ कि कोई कंफ्यूजन कोई आपको कोई एम्बिग्युइटी पिछले जो हमने परफॉर्म इसकी वीडियो भी आपसे शेयर की, कोई इसी तरह का कोई आपको क्वेश्चन हो तो एवरीबॉडी इज वेलकम. जी
नो सर.
इज इट ओके?
यस सर.
ओके. फरीहा हमामा.
Yes, sir.
हाँ भाई कोई क्वेश्चन?
No, sir.
नो. जवाद he is not available.
Yes, sir.
सवाल है जो पूछना चाहो?
No, sir. Everything okay.
आवाज भी यार. मुबीन.
Yes, sir. Yes, sir.
हाँ जी. Any question, any ambiguity, confusion that needs to be clarified?
No, sir. Okay. Everything okay.
Rakib Aruj.
Yes, sir. Yes, sir.
शमसुर रहमान।
सर आवाज आ रही है?
Yes, sir.
हाँ जी। एनी कंफ्यूजन?
No, sir. Thank you.
जुनैरा?
Yes, sir.
कोई क्वेश्चन है?
No, sir.
ओके जी। तो so you will be finding out, you will be drawing the gradation of the curve for finding for the coarse aggregate, and you can see that this is the gradation curve which is provided in the report. If you can if you can prepare report on computers, those will also be welcome. And if you are getting it from the concrete lab, that is also equally good. Okay. So and then you will be writing the comments and observations whatsoever you have observed, any discrepancy, shortcoming or confusion. Okay. So हाँ भी उज़ैर
Yes, sir.
ये अटेंडेंस
Yes, sir. वो स्क्रीनशॉट्स ले लिए मैंने।
जी
सर स्क्रीनशॉट्स ले लिए हैं।
हाँ जी, चलो ठीक है। ओके जी एवरीबॉडी।
सर ये लेक्चर तो सेंड कर दीजिएगा, आपने पिछले भी सेंड नहीं किए।
हाँ हाँ राकिब क्या रकीब यार
सर मैंने कहा ये नोट्स वगैरह सेंड कर दें, हमें शेयर कर दें ताकि हम पढ़ें इनको।
अच्छा ठीक है, ये सीआर जो है वो मेरे से बात कर लेंगे, ठीक है।
ओके सर।
उज़ैर ये मुझे ना, मैं अभी फ़ोन करता हूँ तो या मुझे फ़ोन करके तो ये मुझे बता दे भाई ये क्या कहना चाह रहे हैं, आवाज़ क्लियर नहीं आ रही।
सर वो ये कह रहे हैं कि ये जिन नोट से आप पढ़ा रहे हैं ये शेयर कर दें।
ठीक है, आवाज़ क्लियर अभी नहीं है, चलो ठीक है। ओके जी एवरीबॉडी, थैंक यू, अल्लाह हाफिज़।